We're going to be talking about today about the electronic health record. It's going to be two components to today's talk. So one is for those of you who have not had a chance to work in a healthcare environment, what does it look like when the doctor is scribbling on something or they're typing on the computer? What are they doing? And it's good to know that, for starters, certainly it's just good to know that as a patient. It's certainly going to be helpful for you to know that as a researcher or doing these projects, because it helps you understand. I'm going to teach you not only the jargon that healthcare providers use, but also a little insight into how healthcare providers think about documenting their interaction with you in the electronic health record, because that process is actually sort of very structured. It's been taught the same way for decades at this point. So it's helpful to know what that structure looks like and what information goes where. The second thing that we're going to be talking about today is that how to work with healthcare data. So this may be helpful for those of you, even if you already have a healthcare background, to see if you are doing research or projects with healthcare data, how is healthcare data stored in the backend database system for any electronic health record, which is the overwhelming majority of healthcare facilities in the US and many countries. So once you understand the basics of how that data is stored, you're going to be able to work with data just about in any healthcare institution, whether it be a small clinic out in the countryside or a massive academic hospital like this. And also, like I said, healthcare data from any foreign institution as well, because the way data is stored is pretty similar across all these software programs. And also to teach you a little bit about some of the pitfalls of working with this kind of healthcare data. And again, what is the jargon, how to think about it, healthcare data, how do you request healthcare data if you're interested in a project with it, and again, some of the tools and things that you may consider using. So the first thing to know is that healthcare data comes from a lot of different places, and it's becoming more varied today's day and age. It used to be healthcare data was really very limited to what the individual healthcare provider, doctor, whoever it was handwriting into the system, into literally a file folder. I'm not sure if any of you are still remember when you were patients when doctors were still writing things in the notes, and then you had to you tapped into the front desk, there was this huge just wall of paper records for every patient. You would see people sliding these doors around, trying your particular file for that clinic. So that is still there. And one of the flaws of our modern computerized electronic health record system is that they designed it to make it look like that paper system, which is a terrible idea. And one of the reasons why healthcare providers find the modern computer electronic health record system so frustrating is that the user interface was designed to look like that old-fashioned file folder system, which maybe was okay for back in the day, but it certainly could have been made a lot better. But the other issue is that we're just starting to integrate a lot more information than just what your healthcare provider or healthcare system records about you. So we're starting to integrate information from you, sometimes called patient-reported outcomes. So what you as a patient are experiencing could be something as simple as what you're experiencing in terms of pain. Let's say you have surgery, you had your hip, you broke your hip, you go home, you have surgery. We can ping you by email or some sort of other electronic communication to say, how much pain are you feeling? And we can record that into our electronic health record system and make decisions off of that. We're increasingly using mobile health apps, increasingly using what we call consumer health, so products that are marketed directly from a company to you as a human being, as an individual who happens to be a patient, with things like activity trackers, sleep trackers, like Fitbits. And for the longest time, healthcare organizations were really scared of including that kind of information into the electronic health record. Anybody think of why that might be? What might be some issues about including this wealth of information about what you and what you're experiencing at home into our electronic health record?
Because people can see it.
Certainly security is an issue. Anytime, everything in our electronic health record system is stored in an ultra secure way. It's federally mandated, obviously. And anytime we include more information, we have to have processes in place to import that information in a secure way and protect that information. Because once we store it, or any healthcare, you're responsible for it, right? So you can't just say, well, yeah, the patient came, data came from the patient's Fitbit. Well, yeah, but now you stored it in your computer system, you're responsible for it. So yes, privacy, safety is an important aspect. Any other thoughts? What would happen if your Fitbit or your Apple Watch records your heart rate being 200 at home? You might have read some of these stories about patients realizing their Apple Watch is telling them their heart is racing or going really fast. And then they seek and that prompts them to go seek medical. But what happens if the Apple Watch is recording your heart rate is 200? It automatically transmits that to UCSD. UCSD automatically inputs into your health record. What do you think is going to happen with that information? I'll tell you now, nothing, because we don't have processes in place to review information like that. Just think about it. What is happening when you go see your doctor? Your doctor looks at their schedule this morning. They're like, oh, Koola is going to come and see me in clinic today at 9 o'clock. I better review her health information. Let me look at the blood tests that we ordered last time. Let me make sure that she hasn't had any new medical problems and didn't get hospitalized for a reason. You see that workflow? Now, what happens if instead of just episodic care, your Fitbit or your Apple Watch is constantly submitting thousands of data points to our electronic health record system every single day? We just don't have the model in the modern healthcare institution to be able to review that information and act upon it. So one issue is, and unfortunately we're not really going to be touching on these issues today, but one issue is, as we're trying, gathering all this information, just how do we have the processes in place to either act or not act on that information? This is similar to other issues that we've had with genetic data. So if you go to All of Us and get genomic sequencing, like how should that data be incorporated? If it is incorporated, what do we do with it? What if it shows issues? Are we obligated to act on those issues if it was obtained from a separate company? So these are all issues that are important to thinking about the modern clinical data, what we might call the clinical data warehouse, is how to incorporate this information, how to use it for basic clinical care, but then also thinking about how to use it for research. We've talked a little bit about this before in the sense of, we talked about the spectrum of biomedical informatics, the fact that we go all the way from the molecular, all the way thinking about the society, and we talked a little bit about the fact that clinical informatics has to do with that interaction between the healthcare provider and the patient. So one aspect of this, and thinking about projects and research or whatever it is, using healthcare data, is that electronic healthcare records were designed for two purposes. Number one is to support documentation, in the sense that you got to write what you did, what you talked about, what you thought the issue was for the patient, how to fix it. And number two, it was designed to support billing, because you needed that information and you needed a way to submit that to the insurance company to get paid for the work you did. That was not designed for you to go and do research on it, for you to go and use it for projects or whatever it is. And that causes issues. And that has to do with the notion of primary versus secondary use of data, in the sense that primarily, this system was designed to take care of people. It wasn't designed to do research. This causes issues for a couple different reasons. The first reason is, number one, the governance around it. You need to have processes in place to actually access that data. The second issue is not just theoretical, but in terms of how you design a study. Because when you design a study with existing electronic health record data, there are a lot of pitfalls with designing that study that has to do with the biases involved in recording that data. Again, the data was recorded for a specific purpose, not recorded with the intent of a future study. So these can lead to various biases in terms of data and cause issues for modeling that data. So it's important to think about those issues when you use clinical healthcare record data. So let me sort of give you an example. This is how we teach medicine. This is sort of kind of a hallmark of teaching medicine in medical schools, and it has to do with the patient case. So we start with talking about patient cases. Our medical education, again, has worked for decades. So a 74-year-old woman is admitted to an outside hospital for inflammation of the pancreas called pancreatitis. They have pancreatic pseudocyst, which is a pseudocyst is kind of a hollow ball that's filled with fluid. Concern for pancreatic necrosis. Necrosis means death of tissue. Started on some antibiotics. Antibiotics that are called vancomycin and zosyn. When they came to our hospital, the patient is saying they're having worsening stomach pain. It's crampy in nature, similar to their menstrual cramps. The pain gets better when they receive pain medication. And in addition to that, the patient has noticed a new rash that's appeared in the last 24 hours with fevers up to 101.5 when tested. So the first thing I want to talk about is the structure of clinical documentation that is used for healthcare providers, particularly doctors, physicians, nurse practitioners, physician assistants. This may not be the same structure that is used by other healthcare providers in our system, including nurses, social workers, physical therapists, and a whole host of other people. But at the very least, I can tell you what the structure of clinical documentation is for those types of providers. And again, it's helpful to know that just in general, but it's also helpful to know like what information is in what sections, because when you're doing projects that have to do with clinical data, one of the things you'll be asked is, well, what data exactly is it that you need? And you need to sort of like have an idea of like, well, how is stuff structured? How do doctors think when they document? So that I know which sections of the electronic health record to go to get the information that I want. So in general, the way we think about documentation is the first part is the history of present illness, sometimes also called the subjective. And essentially, that is a narrative description of what's going on. Like, what is the patient experiencing? Sometimes in the patient's own words, but the idea again is that it's usually a narrative description. And that introduces problems that we'll talk about later. We tend to also record what we call the past medical history. So that's essentially like, what other medical problems do you have? Do you have high blood pressure? Do you have diabetes? What surgeries have you had? And in general, the notion is that this information about you as a patient that's happened in the past is relevant to why we're taking care of you right now. This is also relevant because, again, just from a regulatory and billing standpoint, we're required to document it. But the most important notion is that, are there any clues about you as a person and what medical problems you've had in the past that will inform what may be going on right now? We record your family medical history. We record, are you allergic to anything? We record, do you have any medications that you take? Record something called a review of systems, which is just kind of a fancy way of saying, all right, you told me about what's happening right now. Like, you came to the emergency room because you broke your foot. Review of systems is just to be thorough. Is there anything else going on? Headaches? Do you have any changes in your vision? Do you have a cough? Do you have diarrhea? Do you have problems making urine? Do you have rashes? Any other issues? Review systems is sort of this comprehensive check-all list to make sure we haven't missed anything. Then we have physical examinations. This is the part where the doctor, touches you, like stethoscope on you, etc. We have data, which is, laboratory values, x-rays, things like that. And the last section is called assessment and plan, which is the part of the medical record where the healthcare provider documents, hey, here's what I think is going on, or here are the top 3 things that I think may be going on, and here's what I'm going to do about it. Any questions about that? Okay. So here's what the physical examination looks like in terms of what's documented in the electronic health record. So part of it is what we're going to talk about later, what we call structured data. So structured data in the electronic health record is stuff that you might think of as tabular. So stuff that could be like stored in an Excel file. So that usually includes numeric stuff like blood pressure, your weight, your height. You could include laboratory values. And that's distinct from what we sometimes call unstructured data. And the most common form of unstructured data, as I said, is narrative text, like that history of present illness section in terms of what's going on with you. But the physical exam section is this stuff. It's the stuff that, has to do with your vital signs generally, and then it's broken down into usually an organ system of, parts of your body. In general, how are your eyes doing, your heart doing, your lungs doing, etc. And this section may be limited to only what's relevant to what's happening with you right now or why you're at the doctor's office or the hospital right this second. So for example, in this patient's case, they have this rash. This is what the rash looks like. And then here's some blood tests. So then, this is what we call data, is also sort of part of the physical exam section. But again, this is the way, doctors tend to think, like in this kind of order, that you have the first section, sometimes called a subjective, like kind of a narrative description, like what's going on. And then a slightly more structured section, which is the physical examination section, like by organ systems, and then all the data. The point here isn't really to talk about what these individual blood tests and things are. The point is to sort of describe like these sections and what's contained in them. So this section here, right after the physical exam, so in the future, right now, if you're working on projects where you have to look at electronic health record data, doctor's notes, that kind of stuff, you're wondering where they're actually writing about things like laboratory tests, it'll be in this section generally after the section they describe the physical exam. And then, here, for example, is a CAT scan for this patient. They usually in this section will talk about, x-rays, ultrasounds, things like that, and we'll describe what we see and what issues that we've noticed based upon what's in there. Okay, so we talked about the way data is documented, at least from the physician's perspective. Now let's talk about what the data looks like in the backend database. So depending on how you work with clinical data, it may be one or two ways. So the first way is you might actually be opening up the electronic health record system and interacting with it like a healthcare provider does in order to record or abstract information. So you might have a project where someone says, okay, you're going to be working with the 200 patients in my clinic who had preeclampsia during their pregnancy. And they'll say, okay, these are the patients' names. Go ahead and open their chart. Once you have the appropriate approvals to do so, open their chart, read their notes, record this information about them, like these specific blood tests or whatever it is. That process works okay. And that's the way things have been done, again, for decades. But that process works okay when you're talking about 10, 20, 50, 100, maybe a couple hundred people. But the promise of electronic health records, particularly as it has to do with research, is that you're no longer limited to working with the data for just the patients in your clinic, or just the patients that you normally take care of. You have the ability to work with millions of patients' data, which may be required when you're trying to do research on rare medical problems, right? Or when you're trying to do research on modeling really complex situations where the model only works if you have tens of thousands of patient data points. At that point, the old-fashioned way of, okay, you're going to open the patient's chart on the computer, or even more old-fashioned, a paper chart, and you're going to abstract information about the patient, that process breaks down. Like, there's no way to really do that and still leverage the value of an electronic health record system. So how do we access information directly from the electronic health record? And how is that information stored? This is the next portion of what we're going to be talking about today. So for example, this is the Department of Veterans Affairs, sometimes called a corporate or clinical data warehouse. The Department of Veterans Affairs provides healthcare for about 10 to 12 million veterans. It's one of the largest healthcare organizations in America. There's almost 130 hospitals, a few thousand clinics all across the country. So you can imagine there's just a lot of information. There's over 2 billion sort of clinic visits in there. There's over 10 million hospitalizations in there. I mean, there's just billions and billions. And if you talk about like individual vital signs, like blood pressure, now we're talking about trillions of data points. So again, to work with that kind of size data, you need different processes. Here is the way information is stored in our electronic health record system. And this information is stored, again, the point here is not for you to like become experts or even really know by heart what the manufacturer of our electronic health record system, Epic, how they have designed their information backend. But it's helpful for you to at least know some of this jargon because like as you go through projects this summer or just in general when you're working with this, or even if you go on to work in the healthcare field, it's helpful to know like what this sort of looks like because you'll occasionally be in meetings or other stuff where people throw these words around, and it's helpful to know what they're talking about. Most importantly, the stuff in the back, the stuff that you don't see, the database system that's recording everything, there's two types of database systems for the Epic, and again, Epic is the actual name of the manufacturer from Wisconsin who makes UCSD's electronic health record. It's one of the probably the largest electronic health record system manufacturers in the US. So there's two database systems that's worthwhile to start knowing. So one is called Chronicles. So Chronicles is the system that is more real time. So, you know, when the doctor or the nurse, whomever, pulls up the Epic software, whatever they see on the screen, that software is interfacing with Chronicles to be able to like get information about you and display it to the provider. There's a second layer called Clarity. Yeah, that's just the name of it. That's just what these Epic people named it. This is not like official programming name for database systems. This is just like the brand name for what Epic named it. So there's a second layer called Clarity. And again, it's worthwhile knowing this because Clarity is the most common system that we interface with to get data for research projects or other projects when we use data from an Epic system. It's worthwhile knowing that for a couple of reasons. Number one, again, you may be in a meeting, they'll be like, okay, well, we need to like talk, get the information from Clarity or, ask the analyst help. And you're like, what the heck is Clarity? Or why are they using that word? This is why. Because that's the name of the Epic's database system. It's also worth knowing that the Clarity layer is not real time. So the data within Clarity is usually anywhere from 24 to 48 hours old. Now, for the majority of projects that you're going to be doing, both in terms of like day-to-day stuff the hospital or healthcare system needs to do, and you're going to do for research, that's probably irrelevant. You're probably looking at what has happened to patients over a time frame that may be days or months or years. So the fact that the information in Clarity is 24 hours old, probably not relevant to you, but some of you may now or may in the future be working on projects, and there are projects like that at UCSD, where you need to be making decisions about patients in real time. So you need to get the data, get the information from the electronic health record, make some sort of model or do whatever it is you need to do, and return that information to the healthcare provider using real-time data. You cannot do that with Clarity. Clarity, the data is too old for that. This isn't important. This is, again, just a little bit more of the architecture of Epic. Like I said, this is just, I'll just show you slides with you. This is just for your information. Don't worry about it. Now, you're going to have a lecture about databases. Databases, it's really worthwhile to just understand the bare bones of what a database looks like and how to interface with a database system. Like we talked about before, it's just one of those skills that honestly seems very intimidating. It was intimidating to me, honestly. I didn't really know what the heck a database was until you first interface with one and you realize it's nothing really special. All it is for most data, not all, let's be clear, but for most databases, particularly in use, a database system is just a series of files for tabular data. That's really all it is. In fact, this is an actual database system that is actually storing healthcare data. And again, the particular stuff you're seeing on screen isn't relevant, but what is relevant is the fact that what you're seeing on screen is stuff that it kind of looks like an Excel file, right? That's really all a database is. It's a series of Excel files that's organized in a meaningful manner. And in addition, like I said, it's not relevant, but database systems usually use specialized hardware, like computer parts and stuff, to be able to access this information quickly, right? Because unlike an individual Excel file that you open on your laptop, the database system may have billions of Excel files. So you need to have like specialized hardware to make it all work. But at the end of the day, like when people talk about, oh, I need to go to the database, or you talk to someone about getting information, all they're doing is this. They're just accessing information in like a really fancy Excel system. So for example, this, what we call a data table, and again, I'm not gonna like talk about all the vocabulary of describing databases, because you have a lecture on that. And you even have like a workshop on how to interface with the database, which I think is a really useful skill to have. So for example, this, what we call a table in a database system, has to do with hospitalization. So that has information about when they entered the hospital on such and such date, such and such a time, and when they left the hospital, and some information about like a numeric identifier about the patient. So again, nothing fancy, honestly, like really simple, not intimidating at all, about like how the information is stored. So now I'm going to talk to you about a little bit about like, okay, so that's how the information is stored on what I call the backend system, how it's stored in Clarity. Like Clarity looks like this. I'm not showing you a picture of Clarity, but this is exactly what Clarity looks like. Again, nothing super fancy at all. Like after you have that lecture on using SQL later this summer, you would theoretically be able to interface with Clarity without any issues. You wouldn't have the security permissions to do so, but I'm just saying that in theory, if you were given that security permission, it's easy enough to use that just with that 1 or 2 lectures, you'd be able to do that, okay? But once you do that, like once you access this information and let's say someone with the appropriate security clearance accesses Clarity on your behalf and gets information about 2,000 patients. So, earlier we talked about maybe doing patients about everyone who has preeclampsia in my particular clinic. Well, how about every pregnant woman that's ever come to UCSD that had preeclampsia? Let's say there's 15,000 patients like that. I asked my data analyst who works at Health IT to get me like all the information about these patients. Like what is that information going to look like? Or more importantly, like how can I be more specific when I talk to the analyst? Because it's going to be too vague if you simply tell the analyst, oh, get me information about like every pregnant woman at preeclampsia. It's going to be like, okay, well, what is it that you want exactly, right? So it's important to sort of think about it. And this is how I think about healthcare data, how it's stored in the backend database. And whenever I'm requesting information or I'm directly manipulating or analyzing it, I think about 2 data streams. So the first data stream, which I'm going to talk about today, is what we call structured data. So again, I already sort of introduced this terminology, this notion of like essentially stuff that can be fit into a table, right? Usually numbers, laboratory tests, things like this. It's way more complex to think about unstructured data. So what people are writing is like common sentences. I'm going to really focus today on structured data. I'll briefly touch upon unstructured data. Really thinking about unstructured data is really more of the purview of what we call natural language processing. As you may know, like this is really coming to the news because of ChatGPT and stuff like that. But I'll sort of talk a little bit about how to think about unstructured data in the electronic health record, just a very hands-on perspective, okay? All right, so structured data, structured data has a lot of components. It can, it can be a lot of things, honestly, just about anything that can be stored in a tabular format. So structured data is not just limited to what I'm showing you on the screen, okay? But these are some of the most common types of structured data that people tend to use in projects or research that has to do with clinical healthcare records. And it's worthwhile like knowing about that. So it has to do with like diagnoses and procedures and surgeries and things, laboratory tests, vital signs. As I mentioned, vital signs, clinically what we mean are stuff like blood pressure and things like that. But really vital signs, I would sort of think about more broadly as anything that allied healthcare staff, including nurses, case managers, physical therapists, are storing in a tabular environment. And the reason this is important is that there's a whole bunch of information that, for example, in the hospital setting, our nurses store in an interface that's tabular, like tables. So for example, nurses may ask you, like, are you experiencing any pain on a score of 1 to 10? Well, guess what? They're storing that number. You tell them, you say, hey, my pain is a level of 5. They're storing that into a tabular environment. Something in Epic it's called a flow sheet. It's not, again, it's not relevant necessarily that you know that, but it is relevant that kind of data is really, really easy to access and manipulate. That's the important lesson that you should take away. Anything that is stored into a tabular environment, and in Epic, the name for that is called Epic Flow Sheets, is easy to access. And that can include hundreds of different things that is relevant to healthcare research, maybe relevant to projects you're working on, and you may not even be aware that that's how it's stored and it's easy to access. So I'll just include that as part of bios, and then finally, like medications. Okay. So for diagnoses and procedures, when we try to work with that data, well, it's important to know, like, how is that information stored in an electronic health record. So I'll talk a little bit about 3 different ways it's stored. So again, when we record this information, yes, part of why we're recording it is for documentation, right? But the other reason we record diagnoses, like you have high blood pressure or whatever it is, and for procedures like surgeries, is that we need to submit a bill to the insurance company. So it's worthwhile knowing what that information looks like if you ever have to use it and manipulate it, because again, this is a common secondary use of healthcare information. It's worthwhile knowing that this information can be stored in a few different places in an electronic health record. And it's worthwhile thinking about that for various reasons, but at the very least, you should know that it can be stored in what's called a hospital billing database. So that's a database where the healthcare system sends a bill to the insurance for kind of what we call a global bill for so-and-so was hospitalized because they broke their foot, and the hospital charges insurance like $6,000 to take care of you because you broke your foot. That's different what we call a professional billing table, and the professional billing table has to do with billing for individual interactions you had with healthcare providers, specifically, usually mostly just physicians. So the idea is that physicians saw you on June 1st, they interacted with you, they did something for you. They will submit a bill for that interaction on that day. And then they see you again on June 2nd. Again, a physician will submit a bill for that interaction on June 2nd, et cetera. So it's usually a single bill for every physician interaction or an interaction with a nurse practitioner or physician assistant, per day of interaction. And you'll also have structured data in terms of what we call problem lists or medical history. Again, the name of it might be slightly different depending on the specific electronic health record system that you're doing, but it's sort of how to think about that. The other reason to think about these different sources for this kind of information is because the sensitivity and specificity of that information may be different depending on which section of the electronic health record data you're looking for. For example, what may be some things that the hospital billing table would be better for than the professional billing table? Anyone have any ideas as to how, when we pros and cons of using the hospital billing versus professional billing? Well, the hospital billing table, again, it's kind of a global bill. It has to do with what the hospital thinks is the top 5 most important problems that you have that we're taking care of. It tends to be a good table for finding the most important issues, but also it tends to be what we call less noisy. It tends to be more specific because it's kind of gone through several rounds of vetting. Whereas the professional billing table, it's basically what someone thinks is going on in one particular day. And that may be good for picking up smaller problems that the hospital may be less worried about. But if you had a problem for just one day, let's say you're in the hospital for 10 days, and you had a problem for just one day, it's helpful to know that other source, the professional billing table, may have that information when the hospital billing table doesn't. So the next thing to sort of think about is what does that information actually look like? I told you those are the areas that are stored. what does that information look like? So the most common way that information is stored in electronic health records about diagnoses is something called the ICD system, the International Classification of Diseases. It's worthwhile knowing that because it's so common. It's the most common way that healthcare research is done. So if you read almost any healthcare paper, they'll talk about ICD codes, and this is what they're talking about. So these codes have different versions. So the current version in the US is called ICD-10 is what we use. That the way that looks like a code is a letter followed by a series of numbers, may or may not have a letter at the end. Now, this ICD system is just another way of categorizing diseases, all right? It's done for two reasons. Number one, again, remember, all these systems, why they were partly created was to submit bills to the insurance company. And the insurance company didn't want them long-winded, like narrative description of what the doctor thought was wrong with you. They just wanted a really simple way of entering information into the computer to say that, okay, Bob had high blood pressure. I'm going to insert into the computer I10.0, etc. It's worthwhile thinking about some other classification systems as well. Again, it's worthwhile knowing about this if you ever do healthcare research, or you might hear about these systems. There's a lot of them, so I don't want to necessarily spend time talking about all of them, but it's just important to know that the takeaway point is all of these systems are just ways of categorizing diagnoses, so it's easier to deal with. And most of these systems have a hierarchical nature. As is to say that they're meant to have a classification system where you have something more general going to more specific. Like, for example, you might have an ICD chapter for every code that begins with an I, meaning issues with the heart. And then you might have a subchapter for I10, I10, for issues with blood pressure. And then you might have I10.1 or 2 or 3, and again, that has to do with blood pressure because of kidney disease. You see what I mean? So the notion is that these systems are meant to be hierarchical. Again, it's worthwhile knowing that, because when you do data with healthcare research, you need to leverage that hierarchy. You need to be able to say, okay, I'm interested in not just this one specific diagnosis, right? I'm interested in all patients that have this group of diagnoses. And that's easy to do because of the hierarchical nature of the ICD system and other systems that we use to classify data. Well, I'll briefly talk about labs and vitals. Again, we'll talk about, I'll actually come back to labs and vitals. Here's how medication information is stored. And again, this is just hierarchical systems. Don't need to actually know exactly what all these systems are. Just know that most of these systems are hierarchical. And if you're interested in knowing, okay, I want to know all patients who take cholesterol-lowering medications at UCSD, what you're going to need to tell the analyst, or whomever you're working with, is instead of that information about, just saying cholesterol-lowering medications, which may be too generic way to communicate, it's really helpful to be able to specify that information in using one of these hierarchical things. So, for example, these are some different examples of hierarchical systems that we use to record medication information. There's one that's not on here that's also common. It's called RX norm. And again, it's just a way of having a code to describe certain types of medications. And it makes it a lot easier to work with this kind of data, because this is the way the stuff is reported in the backend database, and it makes it a lot easier to request data and work with that data when you at least have some notion of what that looks like. So here's some common pitfalls. So I mentioned I was going to come back to talking about what laboratory information looks like. So laboratory information, again, also has a mechanism to be stored in the backend database. The hierarchical system for laboratory information is called LOINC, L-O-I-N-C. Again, it's just another name, just another hierarchical system. So one common problem with laboratory information in the electronic health record is let's say you're interested in doing a project on kidney disease. Well, the way we usually track kidney disease is by measuring a chemical in the blood called creatinine. So you might think it'd be easy enough to, when you're trying to get that data from the backend system, say, okay, well, I just need all the information about patients with an abnormal creatinine or whatever it is, or maybe you're telling the analyst, hey, I would like to have all the creatinine values stored in our electronic health record system for these 500 patients. Well, if that's all you did, you're going to run into some troubles because there's multiple tests with the word creatinine in it. Some of those tests have to do with blood. Some of those tests are from urine. So if all you do is say, hey, I just want creatinine, you're going to get, the analyst doesn't necessarily have any clinical training, right? So you're going to get all of that information, and they have, semantically, these are very different things. So a creatinine from the blood is very different than measuring it in someone's urine. So in order to deal with that, you can either have, the kind of the domain knowledge to be specific, or you can describe what's happening within that LOINC system. You can say that, hey, I'm interested in these LOINC identifiers, which have to do with creatinine measured in the patient's blood. Or, at least in the EPIC electronic health record system, each blood test or each laboratory test is described what's called a component ID, which is just a number. And it makes it really easy if you're interested in the electronic health record data to say that, hey, I'm interested in creatinine, this specific component ID, 2104, which is the creatinine measured in the blood. Right. The other thing about common pitfall for things like laboratory tests specifically is that you can have just sometimes junk recorded in this data. And that's because the way the laboratory data is recorded in the electronic health record is it's interfacing with external software. It's interfacing with an actual machine that's like, analyzing your blood and stuff. And that machine has software of its own that it's using to record information. That machine is going to transfer information to the electronic record. So you can imagine how stuff will break down during that workflow. When you have a machine that's made by a different manufacturer with its own software, which may be made by a different manufacturer, that's trying to transmit data to the electronic health record, you can get some rubbish stored within the electronic health record. It's just worthwhile knowing that, because again, if you're doing a project and you're requesting data on thousands of patients, you need to take some time to do quality checking that the data that you're receiving makes sense. And laboratory data is one of the most common areas where you can get some junk data in it because of all these ways that data is passed on. Okay. I'm gonna take a pause there for a second. And so I'm gonna talk again very briefly about looking at clinical text data. Again, but any questions about what we talked about already?
Is there a medication adherence number or like structured data in EPIC?
No. So medication adherence as in like, did the patient that were prescribed this antibiotic to take twice a day for 10 days, did they actually do that?
Yeah.
No.
Is there a text data on that or any text data on that?
So medication adherence is not stored. Well, let me take a step back. So I would say that by default, that information is not stored in a specific place. And it is probably what we call variably documented. So we probably only document information like that if we think it's relevant or it's an issue for the problem at hand. So for example, someone, let's say they were came to the emergency room because they felt like they had a urinary infection, they got prescribed an antibiotic. They go home, a week later, they come back. They say, Doc, I'm still having burning in my urine. I mean, one of the first questions you're gonna ask is, okay, well, that makes sense, let's figure out what's going on. You were just here for the same issue a week ago, you were prescribed an antibiotic, did you take that antibiotic? So in that system, what's gonna happen is, again, that narrative section is the most common place. in the HPI or subjective that a healthcare provider will document narratively, like so-and-so was prescribed an antibiotic, they completed the antibiotic or they did not complete the antibiotic. It might also be found in the assessment plan, but the assessment plan is also narrative clinical text. There's one location that it's not really intended to be used the way you're thinking about it, that may record some information about that, and it's a process called medication reconciliation. Medication reconciliation has to do with anytime you have a changes of care. So this in particular has to do when someone's hospitalized, really, but also for clinic visits and stuff. Have you ever been to the doctor's office and they ask you, like, they have a list of your meds, they ask you, Kate, are you taking this med? And Kate says yes. Then say, Kate, are you taking this med? And Kate says, no. Kate, are you taking this med? Kate, are you taking this med? That process is called medication reconciliation. I'm making a joke about it, but it's actually really important. As you can imagine, a lot of errors happen in medicine because we don't record effectively whether a patient is actually taking the medicine we think they're taking. And also, errors happen in medicine because patients go to different healthcare systems, right? Like, if you go to the Sharp Hospital or a Sharp primary care doctor, Sharp is in the healthcare system in San Diego. We don't have access to that. We don't know anything about that. It's not going to be in our computer system or anything. So the only way to know about that is medication reconciliation. So medication reconciliation system in Epic does have a little thing where you can say, yes, the patient's currently taking it, or the patient stopped taking it, or the last time the patient took it was a month ago. The only issue is that it's kind of variably used and probably not used that frequently. So depending on like what project you're working on or what you're interested in doing, that may be a way where sort of what we sometimes call semi-structured data or structured data is stored about medication adherence. But by and large, you probably have to look at narrative data. In other words, like what doctors or other people or pharmacists are writing about what people are actually doing about adherence. Any other questions?
I just had a quick question. So like my project is currently working with a database from, I think, NSQIP. Would that be considered structured or unstructured?
Great. So these are, so you want to tell everybody what that is?
My project?
Well, a little bit, they describe what NSQIP is.
I'm not really too sure. I just know that that's where he kind of pulled our database that our project is working on.
Sure, yeah. So NSQIP, sometimes called NSQIP, is a national database that keeps track of surgical outcomes or things usually associated with surgery and maybe some other things. That's a great point because this notion of databases is not just limited to an individual healthcare organization. Insurance companies will maintain similar databases. National organizations may have databases. NSQIP is a national quality improvement initiative. And yes, so to answer your question, NSQIP will store information, something like this. Now, NSQIP is not going to store all the information that an individual doctor's office or hospital stores, right? Which stores like millions of data points about you or a patient. NSQIP abstracts the information and only stores information that's relevant to their mission, right? So they're interested in surgical quality. They'll say like, this person got this surgery for this diagnosis and maybe like how they did 30 days later or whatever it is. But yes, they're going to use this kind of system to store. So procedures are stored in another hierarchy. The name is usually called CPT codes. But you can always Google them, but just so you know, that's what it is. And diagnoses are going to be stored using usually the ICD system, and that's what it is. So yes, all that stuff is basically stored in just one giant Excel looking thing. Any other questions? Okay. So briefly, I'll talk a little bit about what clinical text data, how to think about it. And again, admittedly, a lot of this has started changing over the last several years as we've moved into different models for natural language processing. So some of this is a little bit outdated, but that being said, in terms of research, and then in terms of how to think about using narrative text data, if you're going to use it. This is one workflow to use it. Okay. So the problem with narrative text data is that unlike structured data or tabular data, narrative text data requires a lot of processing if you're using narrative text from hundreds of patients. Now, if you're only using narrative text from 10 patients, then clearly the easiest thing to do is for a human being to open the patient's chart, read the chart, and then abstract information. But again, that process breaks down when you need to look at thousands or tens of thousands of patients. So that's when we use natural language processing systems to convert that narrative text into something computable. Either way you think about it, depending on whatever processing system you use, you either have to do work on upfront in training a system specifically for your task at hand, or you have to do the work on what I would call the backend. So you can use an out-of-the-box system to process text. I'm not going to spend too much time necessarily. I just want to introduce. Excuse me. I just want to introduce some natural language processing systems, just so that if you're ever interested in this kind of work, then you can actually look it up on yourself and see what it takes to use it. So one natural language processing platform. It's relatively popular. It's popular because it's open source, it's free. It's been around for like a decade or so. It's called CTAKES. The UMLS, the next thing there, is not a natural language processing system, but again, it's one of these hierarchies that we use to store information, that we talk about hierarchies like the ICD system and that kind of stuff. So these are, this is an example natural language processing system. So what does a natural language processing system do for you? Like, why do we use them to try to convert text? Like, you're interested in medication adherence. Why do we use them? And what is it trying to do that a human being does? Well, what's happening is that it does a few different things, kind of like what a human does, or how we've all been taught to read. That stuff, what we call like part-to-speech tagging. So actually the computer will say, all right, this is a verb, this is a subject, this is an article, etc. Just like we were taught in like grammar school about like how to do all that. And that's the computer software is doing that. It's doing parts of speech tagging. The next thing is this isn't necessarily meant to be in order per se, but this is different things that it has to do. The next thing it has to do is negation. In other words, instead of saying the patient has high blood pressure, it's detecting whether the sentence is the patient does not have high blood pressure. So as you can imagine, for any of this sort of stuff, it's really important whether something is stated affirmatively or negatively in order to like do research on it. It looks for things like tense, like conditional tense or subjunctive tense, experiencer, like this is important, like is this sentence talking about the patient or is it like talking about the patient's relative? Like, you know, so-and-so's mother has a history of breast cancer. So the experiencer is an important part of it. The NLP system will map text to an ontology. An ontology is, again, it's a hierarchical information system, like I said, the ICD system for diagnoses, etc. So the natural language processing system takes text and will map it to an ontology. And then finally, it'll try to do something called word sense disambiguation. So this is a fancy way of saying the same word can mean different things. Of course, we know that in the English language, there are plenty of words that are spelled the exact same way. There are lots of puns about these kinds of words. They can mean very different things. But similarly, for medical language as well, when we're talking about stuff, same or very similar words can mean more than one thing. So the system tries to say, okay, it tries to decide of those three things it could theoretically mean, you know, the computer system thinks it's referring to this specific problem or entity. So for example, like I told you CTAKES is a software platform, it's free, like if you're ever interested, you can even like download it, just Google it and download it. So here is narrative text that may be in the subjective section or the HPI like we talked about, you know, doctors writing something about this, like, you know, obviously there's a lot of jargon here. The important thing is that the computer system, like I said, is going through and it's, you know, mapping individual parts. I will also maybe make one side note that this kind of natural language processing is not necessarily the same way some of the natural language systems you read about in the popular media lately work. So stuff like ChatGPT, for that matter, a lot of research natural language processing systems, even for healthcare data, use a slightly different format, usually something called embeddings. Don't need to talk about that right now. But it's just worthwhile in general. These are the issues to convert narrative text into something that's computable for a project. So you have to worry about this software, for example, CTakes. It's going to go through and map parts of speech. It's going to map negation, etc. And then it's going to take individual. It's called named entity recognition. It takes individual words that it thinks it's referring to, like a medical problem or whatever it is, and it maps it onto an ontology. Why is this important? Because, for example, if you're interested in medication adherence, you can ask the system to say, hey, I'm interested in looking at issues, find me all the patients where the subjective text, the narrative text part of the document talks about medication adherence. And the system can try to read through all those texts, and they can say, okay, all these 1,000 patients, these 100 patients, there were issues with medication adherence. Or I want to look at all the patients who had hepatocellular carcinoma. Similarly, you can read through all those texts and say, okay, these are the 100 patients that definitely had it because they talk about it in the text. And what the output of CTakes and other clinical natural language processing systems is that you input it some text, let's say, like I said, the narrative text, and it's going to basically output an Excel file, right? It's going to output this CSV file that says for patient identifier 10043, we did or did not find issues. Did or did not find issues with we did or did not find a mention of hepatocellular carcinoma in their narrative text. So that's how it converts narrative text into something computable, because now you can use that Excel file or CSV file into some sort of other computer program, like we talk about R, Python, whatever it is. And this is all it's really doing right here. Yeah.
Do these NLP programs, are they trainable? So because I imagine there's so much shorthand with all of this, with all the clinical documentation that varies by provider, varies by location. And so how do those get trained to adjust depending on those types of preferences?
Yeah, absolutely, great question. So this kind of goes back to something that I sort of glossed over, but again, this has to do with the issue of doing work up front. So in other words, training the system to recognize the different ways things may be described in a particular institution versus using an off-the-shelf system where you don't have to do training. We'll talk about the pros and cons of both. So yes, you can train the system. The main problem with training the system is not the training per se, is that you need what's called human annotation. So human beings have to read 1,000 patients worth of data, literally sit there on a computer screen and use a little cursor and highlight right, this word means this, and this word means that. So that's the part where things tend to break down, is the human resources required to do that. Now, most really high quality natural language projects, so if you ever read a research paper that did natural language processing or whatever, and there's lots of them, because they're not that complex to read, because you just learned what the basics of what clinical NLP does. High quality papers will talk about that process, human annotation, that we built a gold standard set of data where we reviewed 200 patients' charts, and an abstractor went through and highlighted the text, like this has to do with this. Then, yes, you can use that information to either create a kind of custom machine learning model for natural language processing. And the kinds of models I use are a little bit beyond the talk for today. But in general, the notion is that you create a custom algorithm or model, or even here you can use an off-the-shelf model, but importantly, you have what we call a gold standard label, so the human has annotated some text. That's different from out-of-the-box models. For example, CTAKES is an out-of-the-box model. You do not train CTAKES. CTAKES was trained on like hundreds of thousands of patients' charts already. That's a common paradigm with machine learning and also natural language processing, notion of transferability, that you train it on existing data, but it's transferable with some tweaks to like new data. But the notion is that you're going to, with these out-of-the-box models, you're probably going to get a lot of noise. You're probably going to get a lot of information that may be less relevant. So you need some sort of way to filter the noise out. So you're still going to end up having to do work in order to do that. In my experience, in general, that process, that using the out-of-box system, in terms of the total human capital needed, it tends to be less. And even though you're right, the idiosyncrasies of medical documentation tends to be all over the place. There's spelling errors, grammatical errors. This is why what we call clinical NLP is so much tougher. Like regular NLP is actually really good for like newspaper. Why is that? Why is it really good for newspaper? Because there's an editor, right? There's like a copy editor that's gonna read everything, make sure the grammar is right and the punctuation's right. So it's way easier for a computer system to like parse that information. Clinical text, like doctors like blah, 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 it's full of spelling errors, custom acronyms, all sorts of stuff. That being said, again, my experience is that the out-of-the-box systems tend to work for a surprising number of applications that you're interested in. There may be some issues where, yeah, you're right, like there is some really idiosyncratic way that a particular problem is described or talked about, or just like the idiosyncrasies of a particular institution, or like I said, like for the out-of-the-box system to really work, it needs to be able to map it to an ontology. Maybe your medical problem is so new it's not an ontology, right? Think about NLP researchers in March 2020. They couldn't use an out-of-the-box system to describe COVID, right? Because COVID did not exist in any ontology. So we had to like do some work to do that. Great question. Any other questions?
If the narrative section mentions the ontology, mentions the, without HCC twice, for some reason, will it come out in the ontology twice and then be like an error when you do the statistics?
Yes. Yeah. So so these are all great questions. So yes, the natural, and this is again, you can sort of tell the software different ways to handle these issues, but in general, the output from these out-of-the-box systems, every time a thing is mentioned in your CSV file or your Excel file, it'll say subject ID 101, line number 4, we found this entity, like HCC. Maybe there'll be another column for like negation, and the entity was negated. And then like same subject ID, line number 24, we found this entity, and maybe HCC again. So yes, you gotta do post-processing to say, okay, I have something that's computable, but now I have to say, okay, I want to convert that into a binary thing, 0 or 1. I'm going to say, if the document has more affirmative mentions of HCC, more than negative mentions of HCC, I'm going to say that the patient has HCC. And again, this is not perfect systems, and this is why it requires quality checking. So even though I said that you don't necessarily have to do human annotation like you do when you make a custom model, even for out-of-the-box models, you have to spend some effort to be able to say, okay, patient Sally or patient Bob really does have this disease I'm interested in. Does the NLP system agree with me? You need to build what we call a gold standard data set still. Like we said, it's definitely easier to do than phrase level annotation when you read individual words and highlight them.